Make we continue. Conversion between fraction, decimal, and percent in the Jamaican Patois language. Now, remember say, different Jamaican talk different level of Patois. There are certain people who are mix up, take the Patois. Well, first of all, Patois is a mixture of English and African language. But nowadays there are some people, they mix up the Patois with English and I drown out the Patois, I dilute it, right? But we're going to just deal with the somewhat undiluted type of Patois. But anyway, we could go on with the thing where we're on. In the previous video, we did look at fraction, decimal, and percent. Right now, we're going to look at the actual conversion between fraction, decimal, and percent. So we can see what we're going on. We can look at this first. Fraction to decimal. Right? Now, remember, say, what we are dealing with. Usually, them you know really see they ask you to deal with them things in the past papers. They don't really have a question. We never really see a past paper question where say you feel convert this fraction to percent, right? But it's a matter of understanding the reasoning behind why you do certain things in the maths. Then go to a higher level in the maths. They don't really ask you to convert this fraction to a percent. They ask you to do more than that. But sometimes you have to do the conversion while you solve other problems, you see. So I'm going to say. So anyway, if we saw what go on so. Right? So what they go along right here so. The fraction to decimal. How that go? Suppose and say. Someone would have say, you know. But anyway, fraction to decimal. Suppose you want to convert half to decimal, right? What you can do? I use long division. Suppose you say now, since one of the numerator, you put one here so. And you say 2 into 1. 2 divided into 1. You can't do that. You can't. So you put 0 on the decimal point. Then the usual thing with long division is say 0 times 2. What give you what? 0. You put on the 0 here so. 1 minus 0 are 1. And you multiply this one by 10. You get 10. 2 into 10. 5 times. You have 5 2's in a 10. So you say 2 into 10 goes 5 times. 5, what is that that come from? 5 multiplied by 2 are 10. So you write this a 10 under here. So 10 minus 10 are 0. You know, make no sense to continue so you know. Because you're going to say 2 into 0 goes 0 times. 0 times 2 are 0. 0 minus 0 are 0. Multiply. Oh, you're going to multiply this by 10 and you get 0. Multiply 0 by 10, you get 0. 2 into 0, 0 times. 0 times 2, 0. So you just repeat yourself, so might as well. Once you get 0 on there, so you're done with the long division. Alright? So, half to decimal equal 0.5. When you convert half to decimal, at 0.5 you get. You see that? Now, let me try the next one. Try one next one. Now, suppose you have a quarter. Right? Suppose you have quarter. How you going to deal with that? By the way, what I'm going to do, I ask you if you do it. Do it and make me see. Although I can't go see from here, so. Alright, you do it done? You done? How much you get? I want to know how much you get. Make we see. What going on, so? By the way, I kind of change up the color now. Quarter to decimal. Use long division again. 4 into 1. 4 into 1. You can't. You put 0 on the point, right? 0 times 4 are 0. 1 minus 0 are 1. Multiply 1 by 10, you get 10. And by the way, we're going to look at why you multiply by 10. Let me make a note. Yes, so. Yeah, I write WY, a WH, Y, Y multiply by 10. Alright, we're going to look at that. But anyway, we jot it down right so if you remember. 4 into 10. How much 4s you have in a 10? Now 2. 2 4. 2 4s are 8. 10 minus 8 how much? 2. Then you say multiply 2 by 10. You get 0. 4 into 20. 5 times. 5 by 4 are 20. 20 minus 20 is 0. Alright, that is it, you know. It's 0.25. So you see that? So, quarter to decimal equals 0.25. You see? If you do one more, and see how you go. Let me rub this off. If you want to write off your work, you have to go reverse and go back in the video, go right here off. But now, let me see. Suppose you say 1/8. Why you do that? And tell me what you get. Now, the thing with this is that you do a long division again. Right? Suppose you say 1, 8 into 1. 8 into 1. 0 times you can't. 0 times 8 are 0. 1 minus 0 are 1. 8 into 10. Multiply 1 by 0. 10. 8 into 10. How much 8 you have in a 10? 1. 1 times 8 are 8. 10 minus 8 are 2. Multiply 2 by 10. 8 into 20. How much 8 you have into 20? 8 1, 8, 8 2, 2. 2, 8, 16. 20 minus 16 are 4. Multiply 4 by 10, you get 40. How much 8 you have in a 40? 8 5, 40, so a 5. 5 8, 40. 40 minus 40 are 0, you're done. So, 1 8 or 0.125, right? 0.125. Alright. Let's do one next one. Now, what we're going to try. Suppose you say 3 over 40. Suppose you want to convert that. How are you going to deal with it? Let me see what I know. We have a 3, 40. 40 into 3. You can't. You put 0 point. 0 times 40 are 0. 3 minus 0 are 3. Multiply 3 by 10, you get 10. Right? 40 into 30. You still can't. You have a 0. 0 times 40 are 0. 30 minus 0 are 30. Multiply 30 by 10, you get 300. 40 into 300. I could just use the calculator to save time because we use up all the time or so. So 300 over 40, you get 740 in a 300. So you say 7 times 40. 7 4 is 28, so 280. Then you say 300 minus 280 are 20. Then you say multiply 20 by 10, you get 200, right? 40 into 200. If you have 200 here or so, and you say 40 into 10, cancel 10, 4 into 4, 1, 4 into 25. 40 into 200 goes 5 times. 5 4 is 20, so 200 or so. 200 minus 200 are 0. So you say 0.075, right? I could just test it with the calculator now. And say 3 over 40 how much? 3 over 40 are 0.075, so we're right. Hope that you get, 0.075. So this is 0.075. One more. If we see how this goes. Suppose now you say 5 over 9. Convert this. You try it now. Convert it to decimal and let me see. What you get? If you convert 5 over 9 to decimal, you're going to say 9 and 5 or so. 9 into 5. You can't. 0 point. 0 times 9 is 0. 5 minus 0, 5. Multiply 5 by 10, you get 50. 9 into 50 are 5 times. Now 5 times 40, 9 into 50 are 5 points, but 5 9 into 50 because 5 9 are 45. 5 times 9 are 45. 50 minus 45 are 5. 9 into 5. Right? No, you multiply by 10. 9 into 50 are 5. 5 9, 45. 50 minus 45 are 5. Multiply by 10. 9 into 50, 5 times. 5 9, 45. And then you say, but wait, now the same thing may have to go over and over again. Right? You keep on have to do the same thing over and over again. So you say this decimal, the digit them occur and then reoccurring. So you say this is a recurring decimal. A recurring decimal, right? So one thing you can say is 0.5 and then a dot over it for sure, so the 5 keep on a repeat. It's a recurring decimal, right? So you see that. Now, that's a conversion from decimal to fraction. Now, the question is how you convert them back to decimal. Alright, so we could do a decimal to fraction with the 0.5 and see how you go. Decimal to fraction. So 0.5 to fraction. We're going to convert all of these to fraction and see. 0.5 back to fraction. What you have to do is consider, say, 0.5 or really 0.5 over 1, right? Now, you want whole number over whole number. Which number you can multiply 0.5 by and get a whole number? Alright. The thing is, you know, so you can multiply 0.5 by 2 and get a whole number. Right? If you multiply up so by 2, if you recognize that, if you multiply the top by 2, you have to multiply the bottom by 2 too. 2 over 2 are 1. So it's like you have to multiply by 2 over 2. The number have the same value, but it's going to look different when you multiply by 2 over 2. Because 2 over 2 are the same as 1. So, what you do? If you multiply the 0.5 by 2, you get 1. And if you multiply the bottom part by 2, the denominator, you get 2, right? 1 by 2 are 2. So you get it directly, so. But, although, we recognize quick. So if you multiply the 0.5 by 2, we get a whole number. But the usual way to deal with it, because enough time are other numbers and you can't really see quickly which number you're going to multiply the decimal by if you make it a whole number. So usually you multiply by a 10 or a 100 or a 1000 and so on. So if you multiply 0.5, if you multiply the half 0.5 by 10, so it's like you multiply the top by 10, you have to multiply the bottom by 10 too, right? And when you multiply the numerator, the top by 10, you have to make it 10 times bigger. We have to go compensate now, put it back. So you multiply the denominator by 10, you get it 10 times smaller, right? So, the top part, 0.5 by 10, you get 5 over 1 by 10 or 10. So 5 over 10, that is what you get. Now, you cancel and say how much 5 you have in a 10. Or another way to do it is say 5 over 5 by 2. This now are really 5 over 5 times 1 over 2, you know. But 5 over 5 are 1. So 1 times half and half, so the answer are half, you see that. But anyway, with reasoning we deal with this. So, convert decimal to fraction, you put it over 1, then the numbers them, multiply by 10, 100 or 1000 or whatever, if you get rid of the point business, right? And then you cancel out. Now what about the 0.25? We rub out this and do the 0.25 one. I want this convert to fraction 0.25. 0.25 are the same as 0.25 over 1 divided by 1. When you multiply 0.25 by, forget it as a whole number. But if you multiply 0.25 by 100, it's like you're going to move the point 2 places to the right, so you get 25, right? You can multiply 0.25 by 10 and say a whole number, because 0.25 by 10 are really 2.5 and a whole number that. You have to go further and multiply by 100. So if you multiply up here so by 100, you have to multiply down here so by 100 too. You see? So right here now, what you get? A 0.25 by 100. That gives you 25 divided by 1 by 100, 100. So, 25 over 100 are the same as 25 over 25 by 4. If I have multiplied 25 by 4 to get 100. But 25 by 1 over 25 by 4. But the 25 cancels 25. So what you get is a 1 over 4. That means quarter. You see? Quarter you get this up. The same argument. I want you to do it too. For the 0.125 and the 0.75. Right? Now, As for the recurring decimal, you won't really get it directly. And the method you can use, they don't really have it in the CXC syllabus, right? The method where you can use to convert the recurring decimal directly to the fraction. But anyway, if you try, say 0.555, you're going to get. Now remember, we're going to come to the rounding off at some point. Where you have to stop the number and you have to obey the laws of rounding off, where it say if the next number in line 5 or more, you have to come back and add 1 to this number and get 6. But if it's less than 5, you leave the number alone. But right now, we consider this as 555. If you actually try to convert this to fraction, what you're going to have to do, multiply, consider this as 0.555 over 1. You multiply up yourself by 1000, multiply down yourself by the same 1000, right? And you say, this is 555 over 1000. And then you try your conversion, your thing there, your cancellation. And you say 5 into 555 or 111. 5 into 1000 are 200. Right? And then these are kind of close to the half. Remember, say a 5 over 9. So you say 111 into 200, how much? We just deal with the calculator business and say 200 over 111. How much 111 you have in a 200? You have 1 enough, right? So in this case, you can do an approximation and say since 111, you know it's a little bit more than 110, right? And it's a little bit more than 100. So what you can do is say 111. If you say this is kind of near to 1 over 200, you see, say this, a half. And then, what else you have? 111 are the same as 100 plus 10 plus 1, right? So you say, you do 100 over 200 already. This give you half. Then 10 over 200. We are trying a thing here, so 10 over 200. Give you what? This now, we cancel down and give you 1 over 20. And then 1 over 200. We give you 1 over 20, 1 over 200. And if you add them now, and say half plus 1 over 20 plus 1 over 200. You try a thing with that. Half plus 128 plus 1 over 200. And you kind of say, hold on, let me see something here now. The LCM are 200. 2 into 200. Right? And you kind of go back to the 9, kind of near to the 9 over something there. But if you say 1 over 20, or if you say 100 or 11 over 200, right? 555 over 1000, you're going kind of close to 9 over 5, although it's not so obvious. But as me say, the direct technique to deal with it, right, are other type of maths. You have other type of maths you can use and deal with it. And then that a technique where you have to deal with it, Cape maths. But it's an approximate value you have here, so. You won't get the 5/9 with the technique them I have in the C6 syllabus. But you'd have to use what they call arithmetic progression and sum to infinity business. Because you see, this are 3 decimal places we start, but you go on and on and on. You have 0.555555 go on and on. So you have to use the sum to infinity. Not arithmetic, geometric progression. And the sum to infinity with geometric progression. You get the exact 5/9. But that is what we are dealing with for now. So we'll see you in the next video when the time comes. We're going to continue the conversion.